Hey everyone, I'm excited to show you what we've built. I'll use the ThirdAI dashboard to create and deploy custom content parsing models in a matter of minutes. All you need is a bunch of CPUs with ThirdAI installed on them. It can be on-prem or in the cloud with vCPUs. And now anyone can get to the dashboard by connecting via a browser. By the way, the platform takes care of all other infrastructure heavy lifting. So think auto-scaling, distributing, recovery, and monitoring. We handle all of that. All right. So this is the dashboard, standard login. Immediately, I am greeted with an intuitive page that makes me focus on one thing, building and managing models. As you can see, I've been quite productive. Let's do a little warm-up with a standard model that I built earlier. This is called PII-10, a custom-built language model which parses unstructured content and extracts 10 different types of personally identifiable information such as name, email, and address. Again, these are all models built with ThirdAI's engine on CPUs, and they are designed to work at any scale on any infrastructure, even on edge. We've tested them even on single-core CPUs, so they can work literally anywhere. When I click on the Endpoints button, I'm taken to the Inference Endpoint UI, where I can test and play with the model. The idea is that non-AI experts can validate if the model is something they like or if they want to customize it further. Of course, the model is also accessible via REST endpoints for developers, so you can use it in conjunction with any existing system in the AI ecosystem. I can type a query into the search box just to get a feel for what it does. My name is ThirdMetany. This is our CTO, by the way. I can also insert a whole CSV file. I'm going to show you what that looks like. Each row contains some unstructured text. Let me upload it. See how it detected name, email, address, among other things. You can connect this with any custom connector and parse all the contents in flag and categorize them as needed. Now that we've kind of demonstrated the baseline capability of this model, as you can see, it's very fast. It takes less than 0.1 milliseconds per token and only took a couple hundred milliseconds to process the entire document. Now, I want to start going a little deeper and do something more interesting. What if I wanted to add a custom pattern or label? Let's say a customer that uses my PII-10 model actually wants me to detect vehicle identification numbers or ID numbers like passport numbers and whatnot, or introduce custom defined new patterns for an existing tag that's difficult to do through regex. Now it starts to get real. It starts to become a more interesting problem. Lucky for us, we are in the age of generative AI. I'd say this is where the real value of generative AI comes in. All I have to do is click an example, give it a new tag name, give a couple more examples to help Gen AI figure it out. Give another one maybe. And now for vehicle identification numbers. One more here. All right, very simple. A platform that anyone can use, even non-experts. Now, as I do this, the panel on the right collects this information. And when I submit, this gets sent to the database so that later we can use it for training. Let's go to the model dashboard so I can explain this further. I'll go back here, click on this button, usage dashboard. Okay, this is the model dashboard. At the bottom of the page, we see the feedback that we've collected with a button that says Update Model with User Feedback. Recall that these examples use labels that we haven't seen before. When you click this button, it uses generative AI to generate similar examples, which means that you don't have to work too hard to collect too much data. I want to pause for a bit here and think about the implications. The reason most AI systems don't work was who really has labeled data? No one really has labeled data. And with what we have created, now no one needs labeled data. Within a few hours of generating new examples and training the model on them, your new customized model will be ready to go. In the interest of time though, what I'm going to show you today is another model that I created earlier, but following the same process. What you are seeing is a custom language model that can detect more tags than the previous one. As proof, let me upload the same CSV as before. Here we detected the ID number, an ID number there, and also vehicle identification numbers, another vehicle identification number. So it's clear that this model is capable of doing more than the previous model. Now, of course, we can't really tell how good a model is if we only look at a few examples. Since this is a model that we built on top of another model, we can go back to the dashboard and see metrics. Let's go back there. We're back in the model dashboard now, and we can see metrics on all the tags before and after the last round of training. It seems like before the last round of training, we were at around 90% average accuracy across all tags, and after the last round, we are at around 95%. So that's great because it shows that the model is continuously improving. If we scroll down a little, we'll see more detailed information, examples that we excelled at, as well as examples that could use some improvement. So what this allows you to do is analyze what needs improvement and feed it similar data for future training for even further improvement. You can provide data with the UI that I showed you earlier. So for example, in this case, I can click on the name, make sure that it gets that right next time. And so with this process, you can continuously improve the model's performance on existing tags to fit edge cases or new formats, or you can also use it to teach the model to recognize new patterns and labels. All this without code, without GPUs, so you can allocate your engineers and expensive machines to other workloads. Building custom and accurate AI content parsing is now a matter of showing a few examples of what you want to parse and iterating until you like the model, and then clicking deploy. No code change, no dataset needed, no months-long waiting on AI engineers and developers for iteration, no months-long waiting on hardware either. Now let me tell you why this is disruptive. Firstly, we can identify 5 or 5,000 patterns all with the same latency and cost. It's an unprecedented scalability in terms of the number of patterns that you want to detect. It's because it's just a neural network, not a for loop with a bunch of regular expressions. Second, there's no code change needed for adding more patterns. You can swap the AI model while keeping the old code. Nothing changes, and this AI-first way of doing this is very clean. Third, our latencies are 100 times better than popular foundational models, and there's no rate limit. Fourth, it works with streaming content. And fifth, as always, no GPUs needed, as with any ThirdAI product. Keep them, other teams will need it. Finally, we handle the infrastructure heavy lifting with auto-scaling, disaster recovery, and monitoring built in. We hope you're as excited about this as we are. Thank you.